Okay, so we talked about the wording. You're gonna have to pick. So I would have both on my study sheet. You will pick if it's talking about a picture, blueprint. If you need to say, if you need to add a map here, map is technically a picture, right? When you look at it, I would use diagram, like how much does something measure on the diagram, and how much does that measure in real life and in the actual scenario, right? So if you're looking at a diagram on your science textbook and you look at a cell, I would say, hey, this is a diagram, but the actual cell is much smaller, right? So you expect that. You can translate a scale into a scale factor. This is the one we would like to use most of the time. Okay, we want to turn it into a scale factor so we can actually work with it. What is the difference between this one and this one? Well, it looks like a fraction, yes, but this one can have different units. Units are okay and they can be different. Here we want to get rid of the units, so we need to do some converting to get rid of units, okay? That's the primary goal. All right, page 22. We started with this and we ran out of time. So we were given a scale at 1 centimeter and on a diagram represents 50 meters in actual and real life. We wanted the scale factor. We stacked them and we realized different units. We had to do some converting. We used meters, centimeters. It's a pretty easy conversion. Everything ended up getting canceled out. You end up with this as a fraction. That is my preferred way to answer. Okay, answer it as a fraction. Leave it like that if you must, okay? Then there's decimal and then there's percent, okay? But those are also acceptable. I can give them to you as a percentage. You can turn it into a fraction. This gets me to a side note here, okay? Let's try this. If you ever, let's do this together. Let's go 3 divided by 40, let's say. You get that. If you ever do work and you get a decimal and you would like it to be as a fraction, this calculator helps you with it. You ready for this? You press math, right? Press the math button. And the first option is fraction. So you just hit enter basically. You don't even move down or anything. Just hit fraction. And you're basically going to take this answer and turn it into a fraction. So hit enter again. That's the fraction. It's the simplified fraction. So I no longer give marks for simplifying fractions. So in intro, you probably had to simplify your fractions. Now with this calculator, it doesn't even make sense to give you marks for it because it's very easy to do. Okay? So if you ever need to state something in fractions, this is how you do it. If it doesn't do it, it means that it cannot be done. So if you get a decimal like 8 places and you try this and it doesn't, just gives you another decimal, it means it cannot be written as a fraction, okay, or it just can't do it, okay. Complete side note, right, but I'm kind of revealing features as we go along. B, by how much has the original been reduced? First of all, we knew it was a reduction. Why? Because K was less than 1, or if you want to talk percentages, it was less than 100%. So we knew that it was a reduction. By how much? We go 100 minus that. Okay. You know what? That's very quiet. Okay. All right. Let's keep going. I made a mistake here. I'm going 100 minus. When I go 100, I'm thinking the original, right? This is the original. Or the actual. So I can't subtract this. I need to subtract the 0.02. So my bad. But that's why they make erasers, right? Because of teachers like me. And when you subtract that, you get 99.98. Okay. So I will put next to the next to this, I'll say that's like the new shape. So changed by 99.98%. Okay, so this is like my final statement. So the key here is 100. 100 is our baseline. So if your if K is bigger than 100%, right, you'll take that number, subtract 100 from it, and then you know how much it has been increased by. If K is less than 100%, then you need to take 100 minus that to see how much has it been reduced by. Okay, so that's how that goes. All right, let's try to use this in different ways. When do we use it? How do we use it? So here's our first bigger example. So by the way, I'm telling you, the question in this case says that this is what we would consider our diagram, and this is the dimensions of the actual truck. Okay. A, what is the scale used to produce the diagram? A, we'll do that right next to it. So we want to, if it says scale, we want it like this, diagram, actual. Okay, that's how we want the order of the numbers to be in. Now, can we use the heights in this case of this picture? We cannot because there's an unknown here. But we do know the length of both of these items. So we go 14 inches to 25 feet. And that would answer this question. It's as simple as that. It would just be a one marker. Do you know what you're doing? Okay. Different units are okay. Next, B. What is the scale, right? Determine the scale factor used to produce the diagram. So when it's scale factor, we want this. K is equal to diagram actual in that particular order. So in this case, it would be 14 inches and 25 feet. If you flip the order, any work that follows after will be wrong, unfortunately. It's asking me for the scale factor like actually stated, so I must convert. I'll repeat, because it's asking for the scale factor, I must convert and get rid of all units. If it didn't specifically ask for the scale factor, you could have just kept it like that and used it for further math that we will show you later on. Okay? So in this case, I want to get rid of that, so I'm going to do this. Watch. I know that 1 foot has 12 inches. So inches go with inches, feet go with feet. Conveniently, right? So this is 14 times 1, which is just 14, and 25 times 12. 25 times 12 is 300. And it doesn't say in what specific format, so I'll just leave it like that. I'm going to say, hey, that fraction is actually good. Yes?
I had a question for the first example at the very top when you were talking about how decimals that are irrational can be turned into fractions. Is there ever going to be a situation where we just keep it as, like, let's say 3 is repeating, we just write 3.3 and then that line at the very top?
Okay, yeah, so you're talking, this is an aside. Right, so you're thinking 1/3 is 0.333, right?
Yeah.
I don't want the bar, just do this. Like you can just answer it like that, but if you're supposed to state the scale factor as your final answer, you would round it to 2 decimals. So that would be the rounded. But if you're going to need it to calculate something, just do this. Make sense? Okay, thanks for that question. Stop me anytime. Okay. All right, so our scale factor is this. Just because I want you to practice, let's turn that 14 divided by 300. If I ask for a decimal, right, or You can go 0.05, or you gotta take, so this is where it gets a little tricky, right? You multiply that by 100, and now you round to 2 decimals if you want to state it as a percentage, 4.67%. So it's very interesting. Oh, 6.7. Yeah. That is funny. Yeah. Were you the ones that told me yesterday to use it? I looked it up. It's pretty safe to use it. Yeah. It's amazing how that one kid just got famous, right? Just randomly showing up on that video as well. So it seems to have gone very different places all over the place, right? So that's how social media works. 6.7. See, without even wanting to, I make jokes just like that. All right, so that's that, okay? Why did I circle this one? Because that is, you're done there. I didn't ask you for a decimal, I didn't ask you for a percentage. But this is important for grade 12, okay? Would it be okay to state it as 5%? A lot of students round, and then, hey, times 100, 5%. It's a rounding error. You can state it like that if you want. That's fine if you keep it as a decimal. If you want it as a percentage, you got to use all decimals, multiply it by 100, and then take this answer and state it as a percentage. You'll learn. Don't. That's just half a mark. It's not a big deal. We'll figure it out down the road. Okay, C. Now we do some math with it. Determine the height of the truck on the diagram. It's asking for this. Let's call that X. Okay, I'm going to call this, like in this case, a variable. You could call it H, doesn't matter. So watch what I'm going to do here. You got to make sure you understand this. You could use this, or that. It doesn't matter what you want to use. I'm going to use the fraction to get me started. I'm going to say that K is equal to the height of the diagram over the height of actual. So now I'm getting specific. Now we're talking the height. Right? So this is the formula that's going to help us figure out what's missing. What is K in this case? 14 over 300. So you plug that in. Do we know the height of the diagram? No, that's what they're asking for, so that's my unknown. Do I know the height of the truck? Yes. What is it in? 10 feet. It's feet. So what's the only unit that shows up here is feet. My answer, therefore, is going to be in feet. Okay. So just little things to watch out. So I start where the variable is. I start with the number, right? Cross, multiply, and divide. That's not work. This is work. So you multiply that, divide it by 300. I'll remind you of this. If at the denominator you only have one number, you don't need to worry about brackets. But if you ever have something multiplying down here, right, two numbers multiplying or adding, make sure you add a bracket around that when you enter it, if you want to enter it in one shot, okay? So X is, what, 0.46? Okay. Does it keep going? Yeah, okay, that keeps going. So we're not, I'm going to do this for now. What are we in? We are in feet. The question didn't say find the height in inches, right? But wouldn't it make sense based on this context to state this in inches since the length is in inches, right? So we're just going to go ahead and do that. I will try to be specific on a test or something. So what do we know about feet and inches, right? 1 foot has 12 inches. So basically just multiply your answer by 12. So it's 5.6 inches. This is your best answer, I would say. 4.67 would have been fine. No, 4 point, would have been 0.47, sorry. It's 0.47, not 67. All right. There we go. By how much has the actual truck been reduced? This is D. It's a reduction. How do I know that for sure? Because K is less than 100, okay? I will say that here, reduction, comma, since K is less than 1, K is less than 100%. So it's up to you, right? You can either look at the decimal or the percentage, and you get the same explanation. By how much? We're going to go 100 minus 4.67. That would be 95.33%. So this is an aside, by the way. Okay. You would do that on the side and then just say reduced by 95.33%. I will ask you from time to time, hey, the scale factor is 20%. How much has the original been reduced by? Not 20. You go from 100 to 20, so you reduce by 80%, okay? That's how that works. Okay, I will stop talking for a little bit. I will ask you to try. Let's go to page 23 here. I might set it up for you. Okay, example, the diameter of an animal cell is represented by the scale diagram, right? Has an actual, is actually, the diameter is actually 0.25. So this is what in our wording wise, diagram or actual? This is the diagram. So I will say anything you see on this is the diagram. And this is actually, right? So that's the actual diameter. I think that is a dead giveaway, right? Actually, actual. So use diagram and actual in this case. And I'm going to let you kind of figure it out for now on your own. And I'll take it back up here to correct it. I just want you to kind of see, like, do I get this or am I still a bit unsure? And that's fine. That's part of learning, by the way. But give it a try. You have an eraser, so you might have to erase later on. That's okay. Just make sure you're quiet enough. If you're done this one, you can continue working through it. I'll stop you at one point. All right. Anyways, the diameter of the animal cell, we got that part. State the scale that was used to draw it. So we want diagram, actual, like that in that order. So the scale, my diagram is 4.75 centimeters. Just make sure you have the units there. You can't just drop them, right? And the actual is 0.25 millimeters. Okay, so this is what I would be looking for. However, we don't want decimals. Okay, that's the one. What's blocking us? We don't want decimals. So what's the trick? You treat it like a fraction. So you basically multiply both, or this entire thing by the greatest number of decimals. So if there are 2 decimals, then you'll multiply this by 100. If there are 3 decimals, then you multiply it by 1,000, right? So you just pick the most decimals that show up and just do that. So you end up with 475 centimeters and 25 millimeters. I hope this isn't brand new to you. That's what we do to shift decimals. You just multiply it. If there had just been 1, you multiply it by 10, right? So that is the trick. So you can't have decimals. I'll just make a note here. Note, no decimals. That's the one thing I'm going to ask you to watch out for, okay? Okay, so that's A. Mr. Jackson, can't you reduce that? Yes, you can. But I'm not going to give you marks for it, so it's up to you. State the scale factor that was used to draw the diagram. So now we switch into this one, right? Which is diagram over actual. By the way, what diagram over actual? Like, what are we talking about? What are the only 2 pieces of information that we have from both? The diameter, right? So this is technically saying diameter of diagram and diameter of actual. So sometimes you have to actually write it out if you have more than one dimension at play there. So here we go. Diagram is for, which one should I use, Mr. Dirksen? This one or that one? It doesn't really matter. Doesn't really matter. I'm going to use this one here. What's the problem with that one right there? There's a couple of problems. It's asking me for the actual scale factor, like actually, so I have to clean it up. I can't have any units. Okay, so I'm going to clean it up. What should I use here? 1 centimeter has how many millimeters? I hope you graduate knowing this one at least. 8 millimeters. Okay. So 475 times 10 is 4,750. 25 times 1 is just 25. You could leave it like that, but because it's an improper fraction, I'm going to try and divide and see what happens. It actually ends up being perfectly 190. Okay, so I'm actually just going to say that is equal to 190. So that's the best way to answer there. So K is 190. What would that be as a percentage? What would I have to do to that number? Yes. Multiply it by 100. There you go. Or add 2 zeros, right? Or shift the decimal. So that's 19,000%. Whoa, right? That's a lot. Yes, it's been increased by a lot. Okay. So I'm going to box this one off so we know, like, this is where we did B. That's where we did A. And C goes over here somewhere. Is this an enlargement or reduction? Yeah. Enlargement because K is greater than 100%. That's it. By how much? By 18,000 something, right? 18,900%. And why is that? On the side here, I went 19,000% minus, remember 100 is always our baseline. So if you're wondering, where did I get that from? That's where I got it from. So in this case, I subtract 100 from it because it's greater than 100%. That's it. And then D, is this going to fit in there, hopefully? If the nucleus has an actual diameter of 0.12 millimeters, determine the diameter of the nucleus in the diagram. So in case you need a little refresher, the nucleus is right there, right? It's the center. It's a sphere. And so we want to know what that diameter is. So pay close attention to this part. I'm going to twist things on you a little bit. I could use this one, or this one, or even this one here. Like, remember when we wrote the K at first with different units? I can actually use that one as well when I do calculations. So maybe I'll just stick to the script for today. So I go diagram, actual. K is 190, correct? What am I given? The actual diameter, right? That goes under here, 0.12, and we are in millimeters. And this is going to be my unknown here. I want to know what it is on the diagram. Let me bring this up a little bit for those back there. Let me introduce you to the power of 1. Did you know that any number over 1 is just the number itself? It's just 190, okay? Because sometimes people don't see that this is also cross multiplying and dividing. So you cross multiply and then you divide. We're not going to divide by 1, relax, right? But that way just you know what you need to do. You need to go 0.12 times 190. And then we divide it by 1, sure. And so when you do that, you get 22.8 what? What are we in units? Millimeters, right? Did it ask you to state it in a specific unit? It didn't. But what was my diagram labeled in so far? They've been using centimeters. So I'm just going to show you just so you know, right? So 22.8 millimeters. We're going to multiply it by the fact that 1 centimeter has 10 millimeters. I'm totally fine you just multiplying it by 10. So what do we need to do here? 22.8 times 1 divided by 10. So it's basically 2.28 centimeters. So either or is fine. You don't have to necessarily do that. I just keep on reminding you. Mr. Erickson, what if I used these two here with the units, centimeters and millimeters? You could have done that as well. Because remember, this is still goes with the diagram. This goes with the actual. You would have just kept the units as they are, okay, to do that. All right, a couple of these ones here. So determine the scale factor to create the new shape. So if this is the original, that makes this one the new shape automatically. So how would you figure out the scale factor here? Well, you actually can count. How many boxes does this go that way? 2, 4, 6, right? Where does the original go? Where would the 6 go? Top or bottom? Bottom, 6. And what's this length on the new one? It's 3, correct? So this would be 3 over 6, which is 1/2. That's it. Or 0.5 or 50%. But Mr. Erickson, could I have used this one? Could I have used 4 and 2? Absolutely. So the new is 2. The original is 4. What does that amount to? 2 over 4 is still half, still 0.5. It's 50%. So that's one thing you're going to find. Once you determine the scale factor, it's the same no matter which dimensions you compare. Okay, it doesn't change all of a sudden if you pick the radius or something else, okay? All right. I'm going to ask you for now to work a little bit, so all the way to page 26. So I'm going to say for now, 24 to 26. We don't want to forget how to convert, okay? One more thing, okay, because I'm going to let you, today I'm going to give you a little bit of class time, plus you're watching this, right? Watch video on page 27. And if you thought you had a cool teacher because of 6-7, right, making it into my lesson, I'm even cooler than that, okay? So watch this. If you go to 27, you have a QR code. I don't know, I think it's pretty cool. If you scan that, it's going to take you straight to the video. So you don't even have to look it up on Google Classroom or anything like that. It shows you how to deal with scale diagrams. Scale diagrams, there might be one question on the test, very short. So I want you to practice this on your own by just following the video. But don't worry about it right now. Right now it's just work 24 to 26, right? Those pages, and then 27, you do that at home, okay? I'll pause it here for now. Please ask me if you have questions.